So far we've had practice, if I give you the zeros, building up the equation. So now I want to go the other way. So now I want to be able to find all the zeros given the equation. And I'm going to give you some tools to help get there. One of them we've already done. We've already done some synthetic division. But the idea of finding zeros and factoring are really, really similar. When I factor it, I break it into like these linear pieces, you know, like x plus 5 times x minus 7 or whatever, all those little pieces. And when I find the zeros, I actually go one step further from that. Or maybe, you know, maybe this is a byproduct of it, but I end up with answers like -5 and 7. The things that if I plug back into this equation make it a 0. These aren't the zeros for this. This was just an example. But so I'm going to try and find some zeros for this. And we call them zeros because they're actually the places where the graph of this will cross the x-axis. They're the x-intercepts. They're when y is equal to 0. So one tool that I have, that you have, is your graphing calculator. So what you can do is you can graph this. You know, use that y equals button and go from there. I don't have an emulator, but I think I'll just use Wolfram Alpha. If you haven't used this website, it's fantastic. It's amazing. So I'm just going to enter in what we had. I'm going to enter into Wolfram Alpha this equation, and it should give me some information about this equation. So I'll type it in. Let's see, what y is x to the 4th minus 7x cubed. And again, you could just do this on your graphing calculator. And if I was there, that's what I would show right now. But I'm not. And so I entered it in. Hopefully I entered it in correctly. And I'll hit the compute. And it should, oh yeah, it gives me a graph of it. And here's what I want you to notice on this graph is the zeros, again, you would get a graph like this on your graphing calculator as well. The zeros are where it crosses. So it looks like there's one here at 2, and it looks like there's one at 3. So it looks like 2 and 3 are zeros to this. So what I'm going to do then is I'm going to see if they really are. So basically, 2 and 3 are some potential zeros. It could be, you know, that I couldn't read the graph well, or it's actually 1.9997 or something like that. It's not, but it could be. But so if these are zeros, that means that some factors of this would be, well, what does this make a 0 to? X minus 2 and x minus 3. So that means that this x minus 2 should be a factor of that, and x minus 3 should be a factor of that. So what I can do to check it is I can divide it. I can go this divided by that. So if I wanted to do it long division style, you know, I'd line it up. X minus 2 goes into x to the 4th minus 7x cubed plus 8. But I'm not going to do long division. That's ridiculous. What I'm going to do, sorry if I just messed up your notes, what I'm going to do is synthetic division. So I'm going to use this and divide it into that. So remember, when we do synthetic division, we use the potential 0. So I'm going to have 2 go into this, and I'm just going to grab these coefficients, 1x to the 4th, negative 7x cubed, 18x squareds, negative 22x's, and 12 ones. Do my synthetic division. Remember, in synthetic division, this comes down, and then I go times. And then I add these. So negative 7 plus 2 is negative 5, and then I multiply, negative 10. 18 minus 10, I just add these, is 8. Then 2 times 8 is 16. Negative 22 plus 16 is negative 6. Oh, this looks good. Negative 6 times 2 is negative 12. No remainder? Yes. Also, remember, the remainder theorem tells us that if we had plugged 2 into this, that would be our value. So 2 is a 0 for this. So basically what I did was I divided this whole thing by x minus 2. If I was writing this in factored form, I would say I know that I took an x minus 2 out of it, and what's left over is these. So this was x to the fourth, so now these will be cubed. So it would be x cubed minus 5x squared plus 8x minus 6. So 2 is a 0. Check, that's one of my zeros. And I'm just trying to find all the zeros for this. I'm going to keep going. 3 is a potential 0. So I could go x minus 3 and divide it back into this original thing, but I don't have to do that. I've already taken an x minus 2 out. Let me just see if x minus 3 goes into this. You know, I don't have to go back and do the original because I only took an x minus 2 out of it. So this whole thing, this 1, negative 5, 8, negative 6, I'm going to see if 3 is a root for it. So bring it down, multiply, add, multiply, add, multiply. Oh, again, it's looking good. Boom, that is a 0. So yeah, that's a 0 as well. So what I just done is I factored it again. So now I know that it's x minus 2 times x minus 3 times what's left. This was a cubic, so now this has to be a quadratic. X squared minus 2x plus 2. So I found 2 of the zeros so far. So my zeros that I know so far are 2 and 3. And now I just have this quadratic to solve. And this is going to be our strategy. Pull out these linear pieces as we can, these potential zeros. We can graph it, maybe eyeball where the zeros are, like we did here. Or there'll be some other tools I'll give you later that help us find potential zeros too. Pull out as many as we can, and then when we have a quadratic left, we can either try and factor it or use quadratic formula. And looking at this one, I'm not going to be able to factor that, so I'm going to have to do quadratic formula. So, you know, you might have it in your calculator. That's fine. Use that. I'm going to do it by hand right now. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to keep going. Negative 2 is 2. 2 times 1 is 2. Square root of negative 2 squared is positive 4 minus 4 times 1 is 4 times 2 is 8. So I have 2 plus or minus over 2. 4 minus 8 is negative 4. Oh, look at that. Square root of negative 4. Well, I know the square root of 4 is 2. Square root of the negative part is an I. And notice that whole thing is over 2. Both these things are being divided by that 2. So I'll do that division. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 plus or minus I. So my other two zeros are 1 plus I and 1 minus I. Here's what I want you to notice is this had a degree 4, and we got 4 zeros. And now that degree tells us some information. The degree actually tells us the maximum number of zeros that we can have. It could be less. It could be less than 4, but at most we'll have 4. And if it's less, it's actually called a repeated. I'll show you how to identify those as well.